Hey guys, we have one last thing in the first half of this unit that we're going to talk about today. It's not going to be a super long video. I'm sure y'all are excited to hear that. But today we're going to kind of pull everything that we've learned together about distributions, and we're going to talk about what's called describing a distribution. And these are very typical AP questions. Question number one on the test generally is things coming from the unit that we're in right now. And I would say about 50% of the time you'll see a question number one in the free response of the AP test as a describe the distribution problem. So we're going to have two things we're going to do. We're going to describe a distribution and we're going to compare two distributions. They're going to use very similar, we have this acronym that we're going to use called Cuss. So I'm actually today going to teach you how to cuss. Although I'm sure you all know very well how, but let's not cuss that way, let's cuss this way. Okay, so when you describe a distribution, generally, well, not generally, but always, I'm looking for four things. And it's good that we kind of set up exactly what we're looking for, because when you're asked to describe a distribution, um, it's a very general kind of question. So you're probably just kind of scratching your head like, I don't know what to say. Well, now you'll know exactly what to say. You'll have these four things that you want to talk about. I have kind of written, outlined them all here. Cuss stands for center, unusual features, which would be outliers, gaps, etc. Shape, which we talked about, and then spread. And spread can be a lot of things, but generally it's going to be the lowest number in your data set to the highest number. The center is going to be the median for all practical purposes, unless you are not given the shape of your distribution. Unless you're not given an actual graph to look at. Every once in a while you can use the mean as the center if that's the only information that you're given. If you're given a picture, then I would generally say to use the median, just because I gave you a little note that said, the mean's not going to be super accurate in a skewed distribution, so you generally want to use the median in that sense. And then also in a symmetric distribution, the mean and the median should be about the same. So there doesn't see a need to do it both ways, or to do the mean and the median. Okay, so you can look over these, but I'm more interested in the next page and looking at this example. So this actually came all the way back from the day that we did graphing quantitative variables. It's a different example. Here they have a bunch of miles per gallons of cars, and they have made a dot plot of the data. And now what we want to do is we want to take and look at this dot plot and describe this distribution. So let me... Okay, so here's a dot plot of the data. Problem, describe the shape, center, spread of the distribution. Are there any outliers? So this textbook uses a different anagram. They use SOX, shape, outliers, center, spread. Honestly, I've always been told to cuss, and it sounds kind of funny, so generally that's the easiest thing to remember. Okay, so let's take a look. Shape is sometimes the trickiest, and if we take a look at this, if we start with, well, let's start with center. Now what we could do one of two things. We could count the number of dots we have, or we could somehow figure out how many cars we have here. Does it say in the problem somewhere? 3, 4, 5, 6, 7, 8, 8 times 3. So we have 24. Yeah, there it is right there. Cars. So I can just count 12 in from either side, and I'll find the median. So I have 1, 2, 3, 4, 9, 10, 11, 12. So that value right there. So somewhere between, at 28, we have our median. So this would be the center of our distribution. So we would say, the center of the distribution for highway miles per gallon is approximately 28 miles per gallon. And then we talk about unusual features. You could do one of two things. You could say that these two are outliers. Those look kind of like eyes. That's kind of funny. Or you could say that you have big gaps here. I don't know if I've necessarily mentioned both. One kind of implies the other, but you could talk about both. Let's see what they say. In this, let's not talk about shape yet. They said there are large gaps between the Acura RL at 22, the Rolls-Royce at 18, and the Bentley Arnage at 14. So they talk about gaps, but you could also call these outliers and talk about that as well. So so we did C, which is center. We did U, which is unusual features. Now let's talk about shape. Okay, so this is a little interesting. Sometimes you just kind of have to guess your way through shape because this graph is kind of funny. They don't really actually use names for shape here, but let's see if we can figure out what name we would call this shape. Alright, so we have kind of a mound shape over here. You could almost call it multimodal, but because the peaks are so short, I would probably just call it mound shaped or symmetric. Another thing you could do, you could call it skewed left because you have these outliers, or you could say approximately symmetric with two outliers. Either one I think would be okay. Sometimes this graph is a little difficult to distinguish shape on. I think if I were going to give you a test question, I would make sure that the graph was a little bit more distinguishable than this one. So we have these four things. We talked about center, right? We counted out the center. If you can't count it out, then you just want to approximate it. And you want to get, about half the data on one side and about half the data on the other. We talked about usual features, gaps and outliers. We talked about shape. And now let's do spread, right? We didn't do the fourth one. So we need to figure out what the lowest value is. So that's 14. So we would say the spread is, oh, I'm writing an eraser. My shadow hides it from me. Is going to be from the lowest number, which is 14 miles per gallon, to the highest number, which would be 33 miles per gallon. There's a few other things. They did range. You could also list the range. I think that this statement right here is enough for me, and that would also be enough for AP as well. A few other things that describe spread, and we've heard this before. Interquartile range describes the spread of the data. The regular range, like they gave you here, describes spread. Standard deviation describes spread, but I don't think we generally want to talk about standard deviation when we have outliers or skewed distributions because it's not resistant to those outliers, and they're going to be kind of pulled. The standard deviation is going to be a little bigger than it typically would because you have those two cars over here. Alright, so now that you see how to describe a distribution, let's talk about comparing. And I was a little adamant with you whenever I wrote this out because I always have issues. And it's not in red on your paper, but it's in red on my paper. So, when you want to compare two distributions, you want to discuss these four things that I just taught you. You want to cuss about these two distributions. I'm sure you'll be cussing anyway, because it's a whole crap load to write, but you'll be cussing center, unusual features, shape, spread also. But when you compare two distributions, let's see if I can make it any clearer for you. You have to use a comparative word. So, right here, let's highlight it, even though it's in red. So you will remember, if you say, I was very specific about this. A good comparison is one that uses a comparative word. Right here, smaller. This mean is, or this center is 8, which is smaller than the men's distribution, which is 11.5. All right. The bad comparison would just be to list the two, like this right here, and not give a comparative word. Then all you're doing is describing two distributions. You're not actually comparing them, okay? So what you're going to do is you're going to do this with comparative words for all four, the center, unusual feature, shape, and spread, for this example down here. I know I haven't done an example with you comparing, but I think it's pretty obvious. You're just going to say, look at what I've done here. You can't really use a comparative word for shape because it's not going to be built bigger, smaller, wider, but you can use this word different that I have right there. So this shape is skewed left, which is different from the other distribution, which is approximately symmetric, or however it looks. I'm not sure. So what I want you to do is I want you to work this problem out, number 63. And I want to point something out to you beforehand because they like to trick you by doing the work for you in this histogram right here. So what they've asked you to do is to, okay, explain why the total for women is greater than 100%. You could do that. Make a histogram and then compare the two distributions. That's B and C. All right, so notice that they have this number here. This is the number of women, 89, in this company that make between $10,000 and $15,000 per year. This is actually, these numbers here in this first column under number are your frequencies. So whenever you go to make your histogram, these are going to be the vertical height of your bars. That's kind of redundant, vertical height. Oh well. Are going to be the numbers, right? Because that's all frequency is you figure out, okay, hey, I have 89 people that have make between $10,000 and $15,000. So once you make your two histograms, then you're going to write a few sentences to compare the two distributions. I will tell you whenever you're going to pause the video and do this, and you're going to come back. Whenever I show you my answer, you probably want to pause it and take a look at the graphs, and then I'll scroll down, and you can pause it and take a look at what I've written, because I actually wrote quite a bit, and you'll see why I had to write so much and why I had to be so specific, because you also have to include the context of the problem in any kind of write-up that you do in this class. So you need to make sure that you're including what the data actually means when you're comparing the two distributions. All right, so pause the video, go through and work the problem, and I'll see you back in just a second. Okay, so let's take a look. Here are your two graphs. It took me a little while to make these, and as you see, I have this little funky spot on my graph, on my smart board here. It was messing it up, sorry. So, just do the best you could when you're asked to make graphs like this. They said to use an appropriate scale. I don't know if I did that very well to compare the two distributions, but I think I can see the shape and the spread and all that. I don't have any problems comparing the two. I also forgot to answer part A, and so I stuck it up here. And the reason that the women have more than 100 is just because of rounding error. All right, so now, take a look at this. I used comparative words. I listed the possible outliers. I wasn't very specific here. All I said is I knew it was going to be somewhere between $65,000 and $70,000. So, I hope that you see how to compare two distributions. You can use this example as well as the other example that I gave you to work your homework. Your homework also includes some review problems from the rest of what we've covered, since y'all have a quiz over Unit 1, Day 1 through Unit 1, Day 5 next class. So that will be Friday and Monday, I believe. Y'all have a quiz. So make sure you study it for your quiz. After your quiz, you'll do an activity, and then we'll start lectures again and my fun videos. I'm sure y'all are bored to tears. At the class after that, so that'll be beginning of next week. All right, so study hard. Email me if you have questions, and good luck on your quiz.